Okay, we're finally going to learn what the last value does, C. So if you think back to when we were doing translations on we learned that if the number was inside with the X, then it was a horizontal shift. So this is also inside with the X. It's a horizontal shift. And we call it a phase shift. So BX minus C creates a phase shift, which is a horizontal shift. Normally, when I graph one period, the left endpoint, or where I begin, is at 0, and the right endpoint, or where I finish graphing, is at 2 pi, or it's at the end of my period, however long the period is. So this is going to create a phase shift, though. It's either going to shift it left some so that we don't start at 0. So let's see what that looks like. Oh, so what we'll do is we'll do bx minus c equals the left endpoint, and bx minus c equals the right endpoint, and we'll solve for x to find the new endpoints. So we will solve for x to find the new endpoints. Let's see what one looks like. Let's graph y equals sine of x minus pi. So we ask ourselves all the questions. Okay, so the only thing that's different is we have a C. So we have a phase shift. So in x minus pi, instead of my left endpoint being at 0, my phase shift is going to change it. Instead of my left endpoint being at 2 pi, the phase shift is going to change it. So all we do is we solve for x. So we add pi to both sides. And over here we add pi to both sides. So this is a nice one. You could have figured out what was going to happen just by looking at that, and you would have said that would go right pi units. So instead of starting at 0, we're going to start at pi. So we are going to finish at 3 pi. We're going to start at pi. We still have just a period at 2 pi, so we're going to count by pi over 2 still. This is 3 pi over 2, and this is 5 pi over 2. And let's see, amplitude of 1. So that's the only difference, is that we're just scooted over 1 over pi units. And that's what that looks like. It gets a little more complicated when there is a B and a C in the problem. Okay, let's try another. Okay, let's do this one. So we have a phase shift. First thing, you want to go through all of them. A is 1. B is 2, so the period's going to get affected. C is negative pi, and D is 0. Because it is y equals a sine bx minus c plus d. So C is negative pi. Make sure that stands out. So first thing we want to do is figure out how much the period was affected. So it's 2 pi over b. So it's 2 pi over 2. So the period is just pi. And then we want to figure out the phase shift. So 2x plus pi is equal to our left endpoint, and 2x plus pi is equal to our old right endpoint minus pi divided by 2. Over here, when you subtract pi and divide by 2. So we're going to go from negative pi over 2 to positive pi over 2. From negative 1/2 pi to positive 1/2 pi. That is a length of pi units. So it does agree with the period being pi. So I'm going to have to look more in the center of the graph from negative pi over 2 to positive pi over 2. Halfway between would be 0. Half of pi over 2 is pi over 4, and negative pi over 4. You can always also figure out your x scale. You can take your period and divide it by 4, so we're going to count by pi over 4s. So that might look a little weird to you. So I know I'm going to start at negative pi over 2. So negative pi over 2 plus pi over 4, that's common denominator. That is my next number on the x-axis to be a negative pi over 4. So we can get it that way. And then the negative pi over 4 plus pi over 4 puts us at 0. 0 plus pi over 4 puts us at pi over 4. And pi over 4 plus pi over 4 puts us at pi over 2. Or you can just put your endpoints on and find the halfway between them and then those other halves. All right, we still have an amplitude of 1. I'm going to erase this so I can do my graph. This is cosine, and cosine starts high, crosses, low, crosses, and finishes high. Okay, let's see here. Okay, now A is a half, B is 1, so the period won't be affected. C is pi over 3, so there is a phase shift, and D is 0. When the period isn't affected, you can just think about that. You can just think about shifting it right pi over 3. You don't have to go through the whole left endpoint, right endpoint thing, but you can. So if you'd like, you can do left endpoint is x minus pi over 3 equal to 0, which does put us starting at pi over 3, which is what this right shift would have done. And the right endpoint, add pi over 3, make that fraction. So 6 pi over 3 plus 1 pi over 3 is 7 pi over 3. And that is a 2 pi difference between 1 pi over 3 and 7 pi over 3. So everything looks great. We have an amplitude of a half. We're going to start at pi over 3. We're going to finish at 7 pi over 3. Halfway between that would be 4 pi over 3. But maybe we should do it this way. We're going to take the 2 pi and divide it by 4. Take the period to divide it by 4 to figure out the scale. So that's pi over 2. So that means from your left endpoint, you're going to add pi over 2. So common denominator. Our next point on the x-axis is going to be 5 pi over 6. And this would be, let's do the 4 pi over 3 plus the interval that we'll be counting by. So that is times 2, 8 pi over 6 plus 3 pi over 6, that's 11 pi over 6. Okay, so this looks great. You can ask me about that tomorrow if you need to. Sine starts at 0, height, 0, depth, and 0 again. That's one of the toughest things, figuring out that x scale. What do I need to count by? All right, the last thing I want to talk to you about is what if we have a negative in front of the cosine of x? What does that do? Well, we're going to fall back on what it did in chapter 1. If you had negative in front of x squared, it was a reflection on the x. It flipped it over. That's what it's going to do here. It's going to be a reflection on the x-axis. And what is also not as common is if you had y equals the cosine of a negative x. If it's in there with the x, where the negative's in there affecting the x, that's a reflection on the y-axis. I honestly don't even know if we'll have any of those that we'll graph. Mostly we'll just focus on the reflection on the x. So they are nice to graph. So what I want you to think about is how cosine would normally start at the height. Remember, cosine is the u. How it would normally start here, cross low part, cross high part. The negative, the reflection, makes it do exactly the opposite. Instead, it starts at the low part, it crosses, hits the high part, it crosses, and it does the low part. Same for sine. So sine normally starts at 0, hits its height, 0 hits the low part, and ends at 0. Well, this time, sine's going to start at 0 and go down. It's going to go opposite. So that's what the negative sine x looks like. All right, I have a few I want you to try for me. Let's see. I'm going to go ahead and end the video, and the ones I want you to try should show up here in just a second for you. Okay, here's the 4 I'd like for you to try. Come with your questions tomorrow.